Welcome to Captain Gasser World, your ultimate programming adventure. Here, we will make learning code super fun and exciting. We will build games, fix bugs, and go in technology missions together. Whether you are new to computers or ready for the next level, you are in the right place. So buckle up, junior coders. It's time to blast off into the world of technology. Subscribe now and become part of Captain Gasser's world.
Hey, did you know your computer is kind of like a superhero in a box? I was just playing with my cat Lulu when I thought, wait, what is a computer anyway?
Hi, Jana. Welcome to the digital world. I'm Captain Gasser, your tech guide. A computer is a super smart box that can think fast, solve puzzles, and even make art. It has a brain called a CPU, memory to keep things safe, and you can even talk to it using code.
No way! You mean I can tell it what to do? Like a boss?
Exactly. Computers follow instructions, and you are the boss with code.
I'm gonna learn what's coding next, right, Captain Gasser?
Yes, Cadet Jana. Next mission, coding.
Did you know that coding is like giving a computer a recipe? Last time we learned that computers have brains. But how do I tell my computer what to do? With magic?
No magic here, Jana, just coding. Coding is writing clear steps your computer can follow. Look, this code tells the computer exactly what to do, step by step.
So I'm the chef. And the boss? Wow!
Exactly. With code, you can make games, robots, or even create your own world.
Yes, Captain Gasser, let's create a real code game, please. But wait, how about my awesome cousin Hannah takes over the next episode? She's going to rock it!
I love it. Next episode, it's me and Hannah bringing that real code game to life.
Ready to play your first coding game? Last time we learned with my cousin Jana that coding is like giving a computer a recipe. So Captain Gasser, how do we make a real game with code?
Hi, Hannah. Welcome to my world. Let's watch this. Here, we are using Python. It's a friendly programming language for beginners.
Wow, look at this. The computer listens and talks back. It's like magic, but it's just interactive coding.
Way to go, Hannah. You made the computer talk.
Thanks, Captain Gasser. So what's next?
Have you ever wondered how the internet works? Get ready to find out.
Guess what? Eid al-Adha is coming. So I took a picture of our Udhiya sheep wearing glasses. And I want to send it to my dad, but he's performing Hajj.
Hajj Mubarak to your dad, Hannah. That picture looks amazing. He's going to love it. I've got an idea. Why don't we use the internet to send him your photo? The internet helps our phones, tablets, and computers talk to each other. It's like a giant invisible web that lets us send messages and photos to anyone, anywhere in the world, even all the way to Makkah.
So my picture travels through cables and servers to my dad's phone?
Exactly. Packets, servers, and IP addresses work together to make it happen.
Speaking of cool things, next Sunday is my brother Ali's birthday.
Yep, I've got a fun surprise for him, and we'll explore how the internet really works. And by the way, Eid Mubarak to you and to all our families around the world.
Wow, a digital birthday card just for me?
Yes, Ali, happy birthday.
But Captain Gasser, how did it get to Ali's tablet?
So Hannah, the card is stored on a server. That's like a giant library computer that keeps things safe. When Ali opens the card, it travels in packets, just like little data puzzle pieces that jump across the internet. Each packet knows Ali's IP address, that's like his tablet's home address to make sure it gets there. And protocols, or internet rules, help these packets follow the right path, just like street signs. Then the card is built with three things: HTML, like Lego bricks, JavaScript for cool buttons and moves, and Python, the smart brain running it on the server. Once all the packets arrive, Ali's tablet puts the puzzle together. And just like magic, the card shows up on the screen.
This is the best birthday surprise ever. Thanks, Captain Gasser. But how did my screen know what to show? And who tells it what to do?
Now that's a mystery for our next adventure.
What do Pharaoh's websites and Al Ali Club have in common? Just like the big football giants Real Madrid and Manchester City, Al Ali Club uses special codes to share match scores and stories online. Exactly like hieroglyphs in ancient Egypt, websites use code to talk to fans all over the world.
Wow, you nailed it, Ali. You just solved the mystery from last time. It's all about websites and browsers. So a website is like a digital stadium full of code for pages, games, and scores. And to get inside, you need a browser like Chrome, Safari, or Firefox, which reads code and turns it into text, pictures, and buttons. Then HTML builds structure like stadium walls. Then CSS adds style, jerseys, and colors. And JavaScript brings action like live scores. So when you type a website like FIFA.com, the browser sends an HTTP request to a server where the website files are stored. The server then sends back data in packets. Once the browser receives those packets, it rebuilds the code and renders the page so it looks just right on your screen.
Wow! So that's how the FIFA website shows the game on my tablet? That's awesome!
And for next time, we'll build a secret website. But for now, everyone shout Yalla Ya Ali, make us proud at the FIFA Club World Cup.
Wait, Ronaldo, Messi, and Salah are gonna help us build a website?
Yes, Ali, they heard you cracked the browser mystery last time. Now they want you to build your very own web stadium. So let's think of website building like this. Ronaldo brings the bricks, that's HTML for structure. Messi adds the paint, that's CSS for style. And Salah powers it up, that's JavaScript for action. So let's start with Ronaldo laying down the structure, our very first brick. He's using HTML to shape the stadium, the title, the intro, even the glowing gates. And with those first lines of code, the foundation is set and your web stadium is officially alive. Then it's Messi's time to paint it Al Ali red using CSS. It gives your site color, fonts, and flair, giving your site the same magic Messi brings to the pitch. Smooth, stylish, unforgettable. And now Salah steps in with JavaScript, adding the spark that makes everything work. You click and the website reacts just like cheering fans. Then behind the scenes, when you type in a website, your browser passes the ball to the server. The server sends back the 3 bricks, HTML for structure, CSS for style, and JavaScript for action. Then your browser puts it all together, and your digital stadium appears ready for the world.
Wow, Captain Gasser, that's amazing. But wait, how does the website know I'm in Cairo, not Alexandria?
That's a secret the web is hiding, Ali, and Alexandria is where we'll start to find it.
But wait, how does the website know I'm in Cairo, not Alexandria? Oh, Ali, it must be because of GPS. Let's use it to drive from Cairo to Alexandria and visit the Corniche.
Perfect idea, Hannah. Buckle up. GPS is more than just maps. It's space magic, powered by real tech. GPS stands for Global Positioning System. Over 30 satellites orbit Earth, sending signals non-stop. So your device listens to signals from at least 4 satellites, then uses trilateration, a clever math puzzle to figure out exactly where you are.
And there it is, the Citadel of Cape Bay. GPS got us right here.
Right on target. Satellites use atomic clocks that measure time in billionths of a second. So our GPS knows exactly where we are, like now cruising the Alexandria Corniche.
And now the Lighthouse of Alexandria, it's guiding us, just like GPS.
Exactly. GPS combines satellites, signals, atomic clocks, trilateration, and location services, working together in real time to guide us anywhere.
But Captain Gasser, how do satellites know our distance just from time?
That's the real secret, Hannah. And to find out, we'll need to leave Earth behind. So next time, we're launching into space to uncover how GPS really works.
Captain Gasser, last time we used GPS to drive from Cairo to Alexandria. But how can satellites know our distance just from time?
Great question, Hannah. Buckle up. We're heading to space for the answer. Here is how GPS really works. Over 30 GPS satellites orbit Earth, each carrying atomic clocks. They measure time down to nanoseconds. Each satellite broadcasts a time-stamped signal that travels at the speed of light, about 300,000 kilometers per second. Your device calculates the distance using time and connects to at least 4 satellites. When your phone receives that signal, it calculates how long it took to arrive. Then, it multiplies the speed of the signal by the time it traveled, and that's how it figures out how far away the satellite is. But to find your exact spot on Earth, one satellite isn't enough. And that's where trilateration comes in. Your device connects to at least 4 satellites and draws invisible spheres using those distances. Where all 4 spheres intersect, that's your precise location. So every time you use maps or location services, you're solving a space-powered math puzzle with satellites, atomic timing, radio waves, and relativity all working together.
Wow, so GPS knows where I am, but it doesn't really understand
You got it. Now get ready to unlock the amazing secret of machines that can actually think and learn.